Okay, so experimental design is the first section that you guys did way back. Very first thing we did, chapters 13, 14, 15. That's the very first thing we did. That was our bear hunt. Our bear hunt with the M&Ms. Remember the good old days? And that was a visual bias because y'all didn't see the green M&Ms. Are you blind or what? Okay. And you didn't see the brown ones very well either. Oh, you saw the green ones, but we didn't see the brown because they were dark down in the dirt. Okay. All right. Now, the bottom line is this. The bottom line is this. By the end of the year, we were making an entire decision about the entire population of something from one itty-bitty sample. So, man, that better be a well-collected sample. There is absolutely no recovery from poorly collected data. So, and this page came from Ms. Meltzer. So I trust her, what she's written here on the importance of various things. She says that the first priority in a study is properly collecting and organizing data to avoid common pitfalls. On the advanced placement exam, using standard vocabulary is paramount. So we want to use vocabulary so that they know what we're talking about. It could be the difference between you getting a top score or just, you know, a lower score if you use the correct vocabulary. So, fully yet concisely, don't blabber on forever to hope that you actually include something you're supposed to include. Okay? Explain the methods as well as the reason behind them. I don't think so. But I did push a button on it, and I'm not sure it's working. Okay. All right. So, here we go. The definition of randomization, or the purpose of randomization, is to reduce bias. You have to tuck that away in your brain. Just like the reason that we block, why do we block? Here, that's down here. The reason we block is to reduce variation. The reason we randomize is to reduce bias. You should have those two facts memorized. The definition is the use of chance or probability during the selection process so that any bias is gone and you're not, you know, whether subconscious or consciously choosing things. Okay, remember all these? Voluntary response bias, when only those that choose to participate do. That's the one. If I send out a survey to all the people in the district saying, how do you want your schedule, or, you know, 6 through 12, because all those schedules changed to be 7-period days instead of the block, you know, do you like the new schedule for next year? Do you think people who don't really care or don't feel very strong, they're not going to respond? The people who don't like it a whole lot, who are hacked off because they're not getting out as early as they could, if it was the other, those are the people who are going to respond and say, no, I don't like it. So a lot of people, so you only respond, I don't know. Next, response bias. When participants are put in a position that makes them uncomfortable in telling the truth. For example, if I said, wow, are you doing drugs? Or have you ever done drugs before? Have you ever done drugs before? Then, you know, a person might not tell me the truth because they don't want me to know the truth. Okay? All right. Under coverage, what's that going to be? Certain groups are left out because, okay, I really like this example. A lot of surveys for teenagers are done in the high schools. Well, you know who's undercovered in those? Homeschooled kids and dropouts, exactly. For teenagers, the surveys are not really appropriate if they are, you know, if you think you're going to be missing out on the kids, the dropout kids that have opinions, you know, or the homeschooled kids, okay? So that might not be the best place venue to do that survey, okay? Yeah, probably. All right, now, I don't remember doing this vocabulary word back when we did back in the day. Do you ever remember us talking about selection bias? I don't remember that, but Ms. Meltzer puts it on here, so let's talk about it. It makes sense. Selection bias is when one group is more heavily studied than any other group. If only members of the Sierra Club are surveyed on their opinions of saving the rainforest, then the results will be strongly skewed in environmental direction. How about this? What if I ask just my AP statistics students, how important do you think math classes really are? Okay, well then all of y'all are just going to like say, really, really important, okay? As opposed to if I just ask the general population of Aledo High School, then I'm going to get all those people in Math Bridge who could care less, and so on. And those people in Algebra 3 who could care less. No, I'm just kidding. Okay.
Really?
Oh, yeah, it already is. Okay. So now, oh, okay, this is a good one. Look, this is really important. If we are hoping to, do a test and perform and say something about all of the state of Texas, then is it appropriate to just get information from Aledo? No. So you need to make sure that your subjects have been randomly chosen or your experimental units have been chosen from the population that is being studied so that it is representative. That's the ultimate goal, is you need to have a representative sample. And if you don't think you've gotten a representative sample, then it's worthless. Okay. Next. Yes, we'll have a quiz on this next class. Simple random samples. The best overall method. I have to get grades. Sorry. Oh, well, that's nice. No. Oh, okay, thanks. 100? No, just kidding. Oh, by the way, I forgot to tell you that, see, look, you can get the Spongetastic thing to wear for the class, and then I'll give you a sticker if you just say something really, really Spongetastic. And you said I look really good today, so you get to be the starter. It's magnetic. You get to. So you start off. Okay, thanks. All right. So now, what? Yeah, no, I really intended on it being something for mathematical purposes, but we'll just go with that for now. Now, simple random samples. Simple random samples are the best way of taking a sample because what you do is you number all the possible subjects and then you randomly take all their numbers, okay? A simple random sample is the best. Not necessarily always realistic. Additionally, the chance of getting a biased group is very small whenever you do a simple random sample. Because it was very small chance that you would have randomly chosen something that weird. And taken into consideration, it's also taken into consideration when you have the sampling error or the standard deviation of the sample. Now, Ms. Meltzer puts this as the idiot factor, but it was actually called the moron factor. Do you remember at the beginning of the year when we watched a little video? It was Bill O'Reilly. He was an interviewer, and he was interviewing a guy from the Gallup poll who looked like Mr. Bean. I don't know if you remember that. Okay? All right. And you remember him? Yeah, we watched that and remember him saying, well, what about you? Are you telling me you're going to call 1,000 people and you're going to get a true representation of who's going to vote for who for president of the United States? Okay? What if you just happen to get 1,000, morons when you call them? And then the guy said, well, when you get a representative sample, you need it to be representative of the people that you're doing it. So if all of the people are morons, then we'll get all people that are morons. If only 30% of the people are morons, then we'll get 30% of the people that are morons. Okay? So there you go. So we want to get a representative sample even if some of them are morons. Yes?
Why don't we have qualifications for voting? Like, have to be semi-educated and...
I don't know. It's bad enough, it's hard enough to get people to vote anyway. So here we go. Stratified random samples. Okay, do you remember we typically struggle between clustering and stratifying? So let's review the difference. Sorry, stratified, random sample. Okay. I gave you a visual aid for stratified. Yes. The squirrel was the one with the clusters. Okay, you remember because the squirrel was sitting down there and then there were all these little clusters down below, and he's going to randomly pick a cluster and eat it all. He's randomly picking another cluster, but then he'll eat it all. So clustering is whenever you randomly pick a cluster and you eat the whole thing. For example, all the first grade classes in the entire Aledo ISD from all the elementary schools. If I'm going to get a cluster sample, then I'm going to put all of the first grade teachers' names in a hat. I'm going to randomly pick out 3 of them, and you know what I'm going to do? Survey every single child in those 3 first grade classes. Okay? Now, stratified, remember, I think of like the atmosphere. You have these different layers, and I want to get an equal representation. So I'm going to randomly take 3 air particles from every layer of the atmosphere. Randomly pick 3 air particles from every layer of the atmosphere. Now I feel like I'm getting a sample of all the atmosphere. Let's relate that to first graders. What would that be in first grade terms? Out of all of the first grade classes in Aledo ISD, what am I going to do to have a stratified sample? Sample 3 students from every first grade class in Aledo ISD. That would be a stratified sample, then not stratified. Then I have equal representation. Okay. Okay, the definition says this. When we first group the subjects by some similar characteristic, well, the similar characteristic in this case is their teacher. Okay? And then sample from each group. So I'm going to sample 3 from each first grade teacher. Yeah, that says that. And then clustering says first split the population into similar groups. So that's first grade class, first grade teachers. Then complete a census. That's all of the students of the groups selected. So I'm going to randomly pick 3 first grade classes and do all of the students in that. Okay, are we good with that? Is that good, Megan? Okay, what about systematic? Often done for convenience, you line them up and you choose, say, every 10th person. Put them alphabetically, choose every 10th person. You know what the trick is here, and it's not stated here, but you have to start at a random place. Okay? So that right there is not stated, but don't forget that. All right. Blocking. What's blocking going to do? Reduce variation. The definition of it is creating groups that have similar qualities so that you can reduce variation. For example, if I think that men and women are going to respond differently to cholesterol medicine, then when I do my experiment, I'm going to group the men together, and I'm going to group the women together, and then I'm going to perform 2 parallel experiments. The men are going to have a treatment in a control group. The women are going to have a treatment in a control group, and I'm going to see, and then I can see how the men did amongst themselves. I can see how the women did amongst themselves, and then I could even compare those 2 sets together. Very good point. Actually, it's like stratifying. It says here that somewhere it says it's not. It's in an experiment. Where did I see that? Oh, here it is. Blocking in an experiment is pretty much the same as stratifying when you choose a sample. So blocking is the vocabulary used when you're doing an experiment, and stratifying is when you're getting a sample. Okay. It means you group subjects by something that's the same: gender, age, grade level, political party affiliation, something that you think has a reason for affecting the results due to the nature of the group. And so you group them to reduce that variation. Okay, and you know what a control group is. That's the one that receives no treatment or gets the placebo. How about blindedness? Remember the stuff about being single blind or double blind? Okay, remember the one we had on our test that was with the pill and the injection? And how could the doctor be blinded as well? Because there's some third-party person over here in the lab who knows your Social Security number and knows what thing you're getting. But I, as the nurse or the doctor, I don't know what you're getting. I'm just giving you a pill, and I'm giving you an injection. Now, it could be the placebo pill and the real injection. It could be the real pill and a placebo injection, saline, or it could be both. Okay, it could be both. Now, the saline would be the placebo injection. Okay, well, anyway. But how does he know it's the taste of that and not the taste of the medicine? Anyway, okay. You know what, though? So there you go. So I was going to tell you a story, but I just decided to not. Oh, sorry. No, okay. Here's your quick story. Let me stop this here. There is the story. And so now, so that was about blindedness. What are confounding variables? Now, there's confounding and there's lurking, and we do not have to differentiate between the two. They're both about the same thing. Basically, there are things that you don't know and you cannot account for, but other things out there that are affecting what's going on, and you can't affect it. So you randomize to hopefully control that as much as possible. Generalization. You have to make sure that you're pulling from the population that you're hoping to make a generalization about. Okay? The results can only be generalized to the population randomly selected. If we study only Westwood students, we may draw conclusions only about Westwood students, not all high school students in the state of Texas or certainly in the United States. Okay, do you remember the difference between experiment versus observational study? The difference is experiments impose a treatment. The study just happens and you just look at what's going on. Additionally, only a well-designed, controlled experiment can you make a cause statement about. That, for example, 87.3% of the variation in whatever is accounted for because of the variation in something else. So that was a causal relationship. I said how much of it was caused by something else. All right, so that's all of those notes. Now we're going to, I'm going to close this out because I got to pull it back up with it being blank. And so now we're going to go on to the next part. There are four or five free responses, and we're going to take a look at those, starting with this one.